These are the video notes for assignment 2.6, graphs of basic functions. And some of these functions here on the front page, come back to them later and see if you can name them. First example, determine the intervals of the domain over which each function is continuous. The format is going to be from a number to a number. Okay, on this first one, number 14, negative infinity, from negative infinity, all the way up to x equal 0. So the way we're going to write it is negative infinity to 0, and we're going to put a bracket on that because x is equal to 0. That's part of the graph. Okay, on the next one, you can see right here that there's an open part of the graph. So we're going to have two or a joined interval. So from negative infinity to 1, and then from 1 out here to positive infinity. Okay, so let's determine the brackets here. We're going to have parentheses for the infinity, negative infinity, and then at 1, it is an open circle. Okay, and then for the second part, we're going to union that 1 to infinity. All right, the next example, for each piecewise defined function, find f of negative 5, f of negative 1, f of 0, and f of 3. Well, if we pay attention to our restrictions here, if x is less than 3, the only numbers I can include in that domain would be f of negative 5 and f of negative 1. And in this case, I can also do f of 0. Okay, and then in the other restriction, we have if x is greater than or equal to 3. Okay, so the only thing I can use there is f of 3. And nothing else falls in that category. So I'm going to evaluate the function at f of negative 5. That means I'm going to take negative 5 and substitute it for x. Negative 5 minus 2 is negative 7. Then now I'm going to do f of negative 1. Negative 1 minus 2 is negative 3. And 0 minus 2 is negative 2. Okay, the other function, I'm going to substitute x there. So f of 3 means 5 minus 3, which is 2. All right, on this page here, graph each piecewise function. Okay, let's look at number 26. We have a couple of restrictions. First of all, x has to be less than or equal to 1. And the other restriction is x is greater than 1. So on the graph, if you will draw a very light line there to show where your boundaries are, it'd be easy to graph. Okay, as long as x is less than or equal to 1, you're going to graph y equals negative 2. So at 1, we're going to come down to negative 2 and put a closed circle. Okay, and all of the numbers that are less than are to the left. So when x is 0, negative 2. When x is negative 3, we get negative 2. When x is negative 5, we get negative 2. You can see that your graph is going to the left right there. Okay, the other restriction was for x greater than 1, the function would be y equals positive 2. So if you notice here, x is not equal to 1, but the boundary starts at 1. So we're going to start with an open circle actually at positive 2. Okay. For x equal 2, that's greater than 1, so 2, 2, 3, 2, could choose 5, 2, and so on. So that graph is going to continue to the right. Okay, number 28, we have 3 different restrictions. We have x has to be less than negative 3. X is going to be in between negative 3 and positive 2. And x is going to be greater than 2. Okay, let's see how that looks on the graph. I've put my boundary lines on here at negative 3 and positive 2. So for the first restriction, all of our x values have to come from numbers that are less than negative 3. Okay, for the second restriction, all of our x values have to come from in between negative 3 and positive 2, and they can include negative 3 and positive 2. For the last one, all of our x values have to include numbers greater than positive 2. Okay, so let's see what this function looks like when x is less than negative 3. When x is less than negative 3, we could take a number, let's take negative 3 for example. Negative 2 times negative 3 is positive 6. So 1, 2, 3, 4, 5, 6, and that is going to be an open circle because x cannot be equal to negative 3. Okay, I'm going to choose another number less than negative 3. Let's take negative 5. Negative 2 times negative 5 is positive 10. Okay, and this is going to be a linear graph. Okay, the second restriction in between negative 3 and positive 2, we will evaluate that. 3 times negative 3 is negative 9, and negative 9 minus 1 is negative 10. Okay, this one is going to be a closed-in circle because we can have x equal to negative 3. Okay, and then if I go to the other end of the boundary, which is positive 2, 3 times 2 is 6. 6 minus 1 is positive 5. And that one also will be a closed circle. Okay, I'm just going to take a number in between, like 0. 3 times 0 is 0, and 0 minus 1 is negative 1. Okay, and this is a linear graph. The slope is 3. And we're going to connect all of those points. Okay, that one actually forms a line segment. Okay, the last restriction, x has to be greater than 2. So I'm actually going to start with 2. Negative 4 times 2 is negative 8. And that is going to be an open circle because x is not supposed to be equal to 2. All right, let's choose a number greater, 3. Negative 4 times 3 is negative 12. Okay, so that is a linear graph, and although we don't have a lot of room to graph the whole thing, we can see that it will be decreasing at a slope of 4. Okay, there you have 2 examples of piecewise defined functions. Okay, on this next example, give a rule for each piecewise defined function and also give the domain and range. So what we're going to do is we're going to look at the graph, and I can see that there's an open circle at x equals 0. So x cannot be equal to 0, but it has to be greater than 0. So if x is greater than 0, my function is going to be y equals 1. Okay, the other restriction down here, we have another open circle, and all the numbers are going to the left in the domain there. So if x is less than 0, then I'm going to graph -1. Okay, the domain here, if I start here at -infinity, okay, once I get to 0, there is a hole in the graph. Negative or 0 is not equal to either one of these graphs, so my domain is going to be -infinity to 0, union 0 to +infinity. Okay, the range, if you notice, does not go below -1, and it does not go above +1. So there's only two numbers in the range, -1 and +1. Okay, when I write brackets like this, that means it's a list of numbers. It's not a from and to interval. Okay? All right, this next example here, we're going to do the same thing again. We're going to look at the graph and decide what the function is. This looks like the square root of x. So my function is going to be the square root of x if x is a number equal to 0 or greater than 0. Okay, and then we also have another function down here below. Notice that x is not equal to 0, but everything less than 0 is going to graph the function -3. So -3 is graphed if x is a number that is less than 0. Okay, now looking at the domain of this function, okay, if I look at -infinity all the way up to 0, one of my functions does include 0. Okay, and then everything after that. So my domain is actually going to be -infinity to +infinity for this, and then my range, okay, on this function down here below, -3 is the only value for that one, and then we have all the values from 0, and actually 0 is included, so 0 to +infinity would describe the rest of that function.